meeting starts at 12:30, and so right before.
Okay. Well, okay. So, hi everyone. Sorry that we're getting a little bit of a late start. We've been having technical difficulties. Hopefully, it'll work out okay on your side. I'd like to welcome everyone to the Innovative Field Technologies for Natural Resources Management on DoD Lands technical session. Okay, so somebody just put in a chat, does this page doesn't seem to have a means to jump the group. I hope that means people can, does not mean that people can't see stuff.
Martin, you want to hit record so you can record the session?
Okay, there it goes. Now I can see the presentation, I think.
You should be recording now.
Okay, great. Sorry. So I'm Jean Pan with the Naval Facilities Engineering and Expeditionary Warfare Center, and I'll be moderating the session with Dave Delaney from Erdic Searle. So the last member of our team is Martin Slosarek, who has graciously agreed to be our session Zoom buddy today. We'd also like to thank the NMFWA team, especially Michael, for her help and patience answering all our questions and all our last minute issues that we had today. Thank everyone for their hard work in putting together this workshop and for providing us the opportunity to have this session. So during this technical session, we want to focus on some innovative field technologies that we hope natural resources managers will find useful and something that they can add to their toolboxes. These field technologies are being deployed and developed and demonstrated through various DoD programs to support DoD needs. So we hope that you've all had the chance to review the presentations, but if not, hopefully you'll be interested in checking some of them out after this panel. So first we'll introduce each presenter and then they'll give a brief summary of the technology in their presentation. And if you have any questions for the presenters, please type them into the Passable chat and we'll ask your questions at the end of the introductions. Okay, so our first panelist is Tim Shields. So after a 35-year career as a field researcher on a variety of long-term field biological monitoring projects, Tim began work in 2012 on non-lethal avian management methods with an emphasis on driving problem birds from areas of concern to humans. That has led to his company, Hardshell Labs, to use emerging technology for specific conservation, resource protection, and human safety enhancing applications. Current efforts involve drone and laser-based avian repulsion for bash reduction and resource protection, remote oiling, egg oiling to limit reproduction of problem birds, and the application of 3D printing to the task of very accurately mimicking juvenile tortoises as part of a project to aversely train ravens that prey upon them. So Martin, if you wouldn't mind going to the next slide for Tim, and then I'll turn it over to Tim.
Thank you, Jean. The project I want to talk about today has to do with extending the reach of a very well-established technique called egg oiling, in which a thin layer of oil is applied to birds' eggs. They then fail to hatch but are structurally undamaged, and the adult birds continue taking care of the eggs. What we have done is taken a technique that was limited to use on ground nesting birds and essentially given it wings by attaching what we call a remote fluid application system to an aerial drone. We also use telescoping poles for lower nests. And essentially what we do is append a nozzle to the camera on the drone. That's the aiming device. Essentially the camera becomes the aiming device. Attached also to the drone is an oil reservoir and a pressure source, some way to pressurize the system. And then the final component is a valve that just allows the flow of the oil out the nozzle onto the bird's eggs. In developing this and applying it, we've in the past 5 years oiled over 500 raven nests with 90% mortality of treated eggs. And the next phase of this project is to take advantage of artificial intelligence and sophisticated autonomous navigation capabilities to create a drone that can essentially fly itself up to a nest, recognize the contents of the nest in coordination with the operator, and allow the operator to easily identify a desirable target and then hit it with a shot of oil. The long-term, the point of this is to control populations of problematic birds in and around sensitive areas, and then more regionally as well. So that's the project we're working on, and we're really excited to be working with Hytron, University of South Carolina, and BWCS.
Okay. All right. Thanks, Tim. So our next panelist is David Delaney. Mr. Delaney is a research wildlife biologist working for the U.S. Army Corps' Research Laboratory, Urdick-Searle. He received a master's in forestry ecology from Northern Arizona University and a BS in wildlife management from the University of New Hampshire. He primarily has worked on threatened and endangered species across a variety of DoD facilities. His work has focused on the potential impacts of military and non-military events on wildlife and assessing the effectiveness and efficiency of new field technologies for monitoring wildlife and its habitat. Dave?
Yes, can everybody hear me?
Yes.
Okay, good. Thank you. Yeah, I appreciate the opportunity to present today. What I'm talking about today is kind of a new use of UAS technology. As you know, traditionally, there's sensors that are put on drones, and drones will go over different habitat and collect different data from GIS data, remote sensing, and those kind of things. This part is using a drone as a tool as part of a data mule technology, which allows for ground sensors to be integrated into a communication system, and then transmitting that information from the ground sensors to the drone with a payload package underneath the drone. And so having wireless communication, uploading of that information. This is a study we did over the last couple of years in flights on Barium Goldwater Range in Arizona, and then Naval Base Ventura County on Point Mugu and San Nicolas Island. So we were collecting information from camera traps that are integrated into the system itself, and we were looking at various water sites in Arizona, and then some bird colonies in California. So the novelness of this, again, is using drones in kind of a different way as a drone in a data mule sort of thing, where we have an automated process. We can set up a mission. We have the VTOL units, and the units we're using, they can go out and fly these missions that we have, automate the process, circle over the sites themselves.
Hello?
Download the information. Once we have once things land, we can look at the data that we have and get an understanding of how many pictures were taken, how many more need to be taken. So we have a good process, an automated process with this to be able to collect that information. And novel features of the technology with the wireless capabilities, the automated aspect to it as well with the data collection, the encryption of the data, which is a very important aspect. The optimization of the battery life with this, it's by solar panels and batteries within the system, so you can put it in remote areas and have it function for long periods of time. And again, some of the things we were testing were beyond visual line of sight, beyond telemetry range, and we were doing multiple flights, multiple station visits per flight. What we were trying to ultimately demonstrate was this technology and how it varied compared to the way it's normally done, which are people visiting sites and driving up and visiting these by foot and by car, and trying to show this technology as a way to kind of have a cost-effective way of getting into these kind of dangerous downrange areas or remote areas, and be able to access this data when you might not be able to normally. So thanks. That's all.
Okay.
Just wanted to give you a little, hopefully people will look at the videos as well. So thank you.
All right, thanks, Dave. Our third person is Martin Slosarek. Martin is a co-founder and lead hardware engineer at PicoGrid. He received a Bachelor of Science in Electrical Engineering from NYU Abu Dhabi.
He previously worked as a senior analyst and project manager at McKinsey & Company in Silicon Valley, working with a variety of tech companies in the area. So he is based in the San Francisco Bay Area, California. So Martin?
Hi, everyone. Yeah, so I'll cover a little bit about the PicoGrid project. When it comes to the motivation for the project, natural resource monitoring, especially camera trapping, often happens across vast areas, and sites can be dotted across the landscape. And because the activities are happen in these remote places, resource monitoring heavily relies on manual methods, such as driving, hiking. PicoGrid is there to essentially solve the issue, and in some ways complement, and some other ways substitute these manual methods. What it does is it provides live streams of video and other data from the field, similarly to what a camera trap would, but real time. And that it includes artificial intelligence that classifies photos just into general categories. So you can think about it as video being streamed 24/7, and whenever there are general categories of interest like vehicles, people, or animals, the platform issues alerts to the user. The technology will be demonstrated at Berrien Goldwater East with the support of the National Defense Center for Energy and Environment. And I already alluded to some of the DoD applications, camera trapping being one of them. Some of the other ones are wildfire detection, security, and monitoring of training operations. If you'd like to learn more, please write to me or have a look at my presentation, which is recorded on the Patable site. Other than that, yeah, I'm looking forward to discussing more with our panelists today.
Okay. All right, thanks, Martin. Our fourth panelist is Dr. William Borman. Dr. Borman is an independent conservation scientist and the science director of Hardshell Labs. He received his PhD in ecology from Rutgers University and worked as a research wildlife biologist for the USGS for 15 years. He has studied raven predation on desert tortoises for 30 years and is now deeply involved in developing and testing non-lethal technological tools for predator populations in conservation, military, and agricultural and with agricultural areas. Okay, Bill?
I can't hear you very well, Jean. I think you have finished introducing me. Your voice keeps breaking up, at least for me. But anyhow, thank you for your introduction. And what I'm presenting today is it's an ongoing, exciting project that I've been involved with for the past few years. It involves a threatened species, 3D printing, and species. And it has implications for condition taste monitoring or condition taste aversion that I touch on, and whole lot of other potential applications. For this project, we made 3D printed, very realistic looking models of juvenile desert tortoises. And the idea of these is to trick ravens, which are a predator on juvenile tortoises, into believing that these 3D printed tortoises, and this is so that we could document predation, model predation risk, monitor the effectiveness of management actions, and then we're also training models for condition taste aversion. And in my presentation, I talk about the results of field season from a year and a half ago, where we placed over 250 user and recorded activities, how animals responded to them. So that's what my talk is about. Thank you.
Okay. Thanks, Bill. And last but not least on our panel is Dr. Charles Casey. Dr. Casey is head of engineering at Hytron Technologies Incorporated, a private research and development company specializing in practical robotics and electronic solutions. He received his PhD in electrical engineering from the University of Kentucky in 2011. At Hytron Technologies, he's worked on numerous R&D projects for the Department of Defense and Department of Homeland Security, including the development of automated camera solutions, novel microfabrication technologies, and autonomous platforms. His professional experience covers a wide range of areas required for the creation of new technologies and prototype designs, from electronics and software development to 3D modeling and mechanical fabrication. As Hytron's head of engineering, he has acted as principal investigator for multiple SBIR phase 1 and phase 2 contracts, including the project presented here, an autonomous robotic device for tick collection. Okay, so Charles?
Hello. Thanks. Our project, the automated tick collecting device, tick collection robot, aka the TicoBot, it's being developed by Hytron Technologies with the assistance of the University of Cincinnati as part of the Phase 2 Department of Defense DHA Small Business Innovation Research Contract. The primary function of the TicoBot is to autonomously navigate outdoor areas and perform tick collection activities for medical research purposes. And this collection can be active, in which the robot mimics the human collector by dragging collection sheets through potential tick habitats or questing areas, or the collection can be passive through the use of the robot's trap and attractant chamber module. And the unit also includes a number of convenient features, including a user interface smartphone app for control and mapping, and a dedicated attractant dispersal and trapping unit with real-time electronic specimen counting that can be linked directly to the control app for continuous monitoring of tick population hotspots. Now, beyond its application for specimen collection, we are hoping that the TicoBot can be a convenient solution for a general purpose outdoor robotic platform for development, research, or ecological monitoring purposes.
Okay. All right. Thanks, Charles. So I'll go ahead and start on the questions now. There were a couple that came in earlier, so I'll ask those, and then if anybody has other questions, please feel free to put them in the chat, and I'll ask those as those come up too. So the ones that came up from the presentations earlier, the first one was from Brendan Myers, and this is for Tim. Were the oil spray systems developed using 3D printing technology? And if so, would these plans be made open source for others to use?
We did use 3D printing for some of the housings and also for the collar that fits around the drone camera, that also essentially that affixes the nozzle to the camera. So what we've done is as the camera pans or moves, the nozzle moves with it, and the collar that does that is 3D printed. Potentially, yes, but I think in the long term, what would happen, the way this would happen, and it would be a while from now, would be if we came up with RFAS units, the remote fluid application system units, for specific drone types. So far, we are not, we're using these things in-house, and they are custom built per drone. But ultimately, we could eventually get to that point. The 3D printed parts would not be the most significant portion, but we could eventually do that open source for sure.
Okay. All right, thank you. And then another question had come in for Dave from Kurt Mosley. So he noticed solar panels on the ground stations. Are they primarily solar powered? And how often do the batteries need to be changed?
Yes. So again, yeah, the system, it's solar panel, and then the camera trap specifically. And so these units are designed to be able to last for extended periods of time. So the solar power is providing all the necessary power for the communication aspects of it. The camera trap has its own battery sources. So again, that can go, especially with lithium batteries and such, can go for, probably 6 months, depending on the amount of activity at the site. So the system itself, again, is solar powered. The battery has a battery within the communication box itself that, again, is a low draw system specifically. So when the aircraft approaches and downloads the information, everything's kind of wound up and the data is transferred. When the plane continues on, the airframe continues on, it goes into a low power draw situation, so it can extend over extended periods of time.
Okay. All right. So a couple of questions have come in through chat. The first one is from Reese Evans, and this is for Dr. Borman, Bill. So ravens have learned to avoid artificial snowy plover eggs filled with a taste diversion chemicals, and they sometimes use quail eggs too. So do you think they're going to learn to avoid technotorts eventually as well? I think that's some interesting answers here.
Hi, Reese. Long time no see. Yeah, absolutely. That is one of the next applications that we're interested in trying out with the systems. We can very easily print very accurate snowy plover eggs, least tern eggs, sage grouse eggs, and we're still working on miniaturizing the components enough to get into all of those eggs, but we probably should be there within the next year or two, so we can just place eggs into them. We can also use these 3D printed eggs in those nests to place sensors in them to monitor various gases and temperature, humidity, things like that. So there's a lot of potential applications, and I'm sure we can use them with plovers and others.
So, but do you think they're going to learn to avoid the technotorts eventually?
Oh, specifically to avoid them, I'm sorry. We just don't know. Our hope is that they don't. We've worked very hard on making them look as accurate and as realistic as possible. We haven't done long enough training with the ravens to determine if they're learning to distinguish between them. So that specific question, I don't know. But okay. I think if they will respond to quail eggs and not learn that quail eggs are not plover eggs, then I think they can. I think that they'll work against at least ravens for plovers.
Okay.
And if I could, it's Tim Shields here. If I could just jump in, I work with Dr. Borman on this project, and we have anticipated the problem of habituation. And one way possible to get around that is to roboticize the tortoises so that they move. So it will be a sort of a chess game with the ravens. And if they show signs of habituation, there are other moves we can make, particularly since, unlike eggs, juvenile tortoises are mobile. We can simulate juvenile tortoise mobility with the lures.
Okay. All right. We have another question here from Rhiannon Papel. So those that are using drones for wildlife plant surveys over military training lands, how are you going about getting the proper permissions? I'm told it's a security issue to take photos and storing information. And we had some follow-up comments where people were saying it's not a security issue for the images, but maybe just speak a little bit about how did you go about getting permissions to fly. And it does vary by service, I will say that.
So yeah, this is Dave. Again, for our project, we weren't taking pictures directly using the drone. Of course, we were just transferring them from the ground, so we didn't run into that issue specifically. But for my organization, a couple of years ago when we started, we had to stand up a UAS program. We didn't really have that within the U.S. Army Corps of Engineers. So there's certainly been some efforts, a lot of effort on a lot of people's part to kind of get that stood up to where we have an office now and personnel that. So when we have projects that are coming down the line, we have to submit information on what the project is, what the airframe is specifically, what and there's certain questions about the kind of the specs associated with those. There's a white list, a kind of an approved list for, as we all know, the DJI and other things. There's issues with the Chinese-made drone applications. So again, there's questionnaires that we have to answer about the specs and make sure it either fits in or we can put in another airframe to try to get permission to have that added to our list. When it comes to coordination with installations, again, for our project with the Navy and the Air Force, and it was working with our contacts, getting permissions. As one of the things for my project, for that project, as a federal worker, I was authorized to fly on. They were not interested necessarily in having contractors fly on the land, and again, that's going to vary based on the part of the country or the service itself. So again, we just were coordinating with them as best we could and getting permission with that. Our system is air gapped, so we don't have any issues with transmitting of information to things that are on a Navy computer or an Air Force computer. We didn't run into those issues specifically. As we know, this is kind of a difficult and kind of involved topic, so I really can't get into too much detail here other than kind of talk a little bit about my experiences there. So thanks.
Okay. Yeah, and if you had any questions, we'd be happy to talk about that more later as well. It just, Dave, are you saying something?
No.
Okay. So and like I said, it does vary from services. You will have to go and get basically cybersecurity waiver approval from your particular service to allow you to actually do the operation, as well as follow whatever procedure is established for you to actually have an active program. And that seems to vary quite a bit between the services. Okay, so let's see. Okay. So a couple of other, here's another question. Anyone have experience using drones or the satellite connected devices for real-time mitigation during training activities? Oh, sorry, I'm gonna unmute you guys. I was muting some, I had muted some people before because there was some background noise, but
yeah, Jean, this is Martin. I'm happy to I think answer part of that question. So if you look at if you look at the DoD lands, training grounds are frequently in pretty remote locations, so cellular is not really an option. So then it's either the drones or the satellite to get real-time data. And with PicoGrid, we're looking at the satellite avenue. So yeah, we can get real-time video and other sensor data over satellite connection, and then push it into a DoD workstation. I think this has the benefit of, I think it's a great question because it does have the benefit of being able to detect any kind of events or potential environmental impact of activities early, versus waiting for when they would already have happened. Yeah, so that's my that's how I look at this. I don't know if Dave has another point of view there.
Yeah, can I speak to that for a second?
Yeah, go ahead, Dave. We're having a little bit hard time hearing you though.
Okay.
Dave, it might be worthwhile if you turn on your video.
Hear me now? Okay, I will try it. Can people hear me now?
Much better.
Much better.
Okay. Sorry about that. So again, like the Barium Goldwater Range East as an example, and these are things, we've got that picogrid project coming up here. Some of the interest here from I think where the question is coming from, is there, let's say, wildlife activity happening in an area where there might be concerns, and then having military activity in same places. Sometimes for barium goldwater and other places, they want to make sure there aren't any sensitive animals in those training areas before they start training. So a technology like this could help in that situation. We have video cameras that are recording an area. They could see animals entering a zone, and be able to get real-time responses that there's animals in an area, and then be able to have the military get that information and make those determinations to train or not. So I think this technology, the picogrid technology, has the capability. We haven't started that project. We will be fielding that this year. So that's definitely part of what this sort of technology can provide a benefit to, is getting real world kind of information from an area, and having managers be able to get that in a timely fashion to make decisions on their training or field work or other kind of things. Thanks.
Anyone else on the panel want to address that? Otherwise, we can move on to our next question. So here's a question for Tim. Have you been able to overcome military aircraft drone conflicts in order to test your egg oiling technology for bash control on or near airfields?
Not yet, but that's on our radar screen. And to kind of give a little bit of background, our thought is that reducing problem bird reproduction in the vicinity of aviation facilities is desirable, and the long-term implications may be that if we consistently oil nests in the vicinity of those facilities, that the birds will ultimately abandon them. But that's a long-term research question. We are going to tackle this idea of using egg oiling in the vicinity of those facilities for bash reduction, bird aircraft strike hazard reduction, and it will be a challenge. And that's the idea of having a DoD partner, is to work out the details of the relationship during these development projects like the SBIRs. It's to figure out, okay, how can we operate in coordination with the normal operations of the facilities. And it will be a case-by-case basis. I think that'll be a definite challenge, but we're going to give it a shot.
Oh, I forgot to mention that question was from Tiffany Shepard. And I will say, Tiffany, that it's part of the SBIR that Tim mentioned, that one of the tasks in there is to demonstrate the automated oiling system, autonomous automated oiling system, ideally on a DoD base. So we will be looking for a partner probably about 2 to 3 years from now. So if anybody's interested,
yeah,
please let us know.
Sign up.
For the actual oiling part, though, that may be something of interest earlier. So that is also something we can, I'm sure Tim would be happy to chat about. Okay. Let's see, another question that had come up is from Dave McNaughton. Like, how often are the cameras being field checked on the tortoise models? Does it take a lot of field time to keep an eye on the models, keep the predators from dragging the models too far away?
Yeah, this is Bill. No, it's not. Well, first of all, the first part of your question about how often are they field checked? Because we're developing the methods, we check them every week or two, but we've had cameras out with the Technotorch for as long as 3 to 4 months. They don't need to be checked regularly. And that's partly because of the answer to your second question. We don't have a problem with predators dragging the models away because we anchor the models. you're usually using fishing line attached to a spike or nail that is at the other end is attached to the Technotort. So they might try to get away with it, but they can't.
Okay.
But
Interesting.
actually, Jean, while I have it, can I answer
Yes.
Martin's question about
Yes, I was just about to mention that.
DRC 1339? Oh, okay.
No, go ahead.
Yeah. So Martin. Yeah, Martin. The eggs and the Technotorts and anything else we did, they could be. We could put DRC 1339 in them. And for those who don't know, DRC 1339 is also called avicide. It's a very, very effective method for killing some species of birds, including ravens. But we're also working with not just conditioned taste aversion, but conditioned scare aversion, for want of a better term. And so along with spraying nasty tasting and smelling chemical in the raven's face, we're also experimenting with using sound, loud or scary or irritating sound. We've talked about flashing lights, just things to go along with it that would help to reinforce the negative experience. So we could use 1339, but we're trying to find other non-lethal alternatives also.
Okay. And then there was a comment about the anchors when you're talking about anchoring your Technotorts. Might be how like ravens would learn to avoid them. So that's an interesting thought that might be something to cue them in on. This is not a real desert tortoise.
Yeah, it's right.
So I think we have about 3 minutes left.
We try to hide.
Okay, so we have about 3 minutes left in this sessions. I don't know if you have any other questions, please feel free to type them in the chat. If not, we have some other questions that we can address before we toward the end of the session. So for all the panelists, I would say, how does your technology improve on current field methods? And how does it benefit the natural resource or the species? Some of you have already, I think, pointed that out, but I wanted to give a chance to everyone to sort of talk about that. So why don't we go ahead and start with Tim. We'll go down the line like we did for the introductions. So Tim, you may have to unmute yourself. I had muted you just to kind of keep background noise.
I will now speak. The egg oiling is a really effective technique, and what we've done is extend the reach through attaching an oiling system to a drone. We've extended the number of species we can treat with egg oiling, and the number of circumstances and the nests that would previously be absolutely untreatable now come within the realm of treatability. And so I think that's the principal advantage. And you know, the reduction of predation we have preliminary data on the reduction of predation pressure both on sage grouse and desert tortoises around nests whose eggs we oil. So we're pursuing that, and we think we can actually quantify the benefit to T&E species. And the same would ultimately be true with bash hazard reduction. If we do have success, we should be able to show that in a reduced number of bird aircraft strikes as 2 examples.
Thanks, Tim. Dave?
Yeah, so examples for the drone data mule that we were talking about is if you had a nesting colony and you can't get in there to collect data or to maintain your cameras that are in there. Again, this allows you a capability to get in, to fly in and download the information when you might be excluded, or if there's access issues downrange and you can't get in by a ground source and you have to do it by the drone. It just allows you that increased capability during difficult access times. And so a variety of species, especially nesting birds, if there's, like we said, different situation like that where you just don't have access, this provides a capability of collecting data more frequently, which is helpful if you're trying to make determinations on nesting predation and other things that you might not be able to find out till later in the season.
Okay. And then Martin, and if you, yeah, so we're already like at the 10:15. So if you guys could just maybe do a 30-second for the last three here.
Sounds good. Yeah, we already hinted at the real-time data, which can be useful for invasive species monitoring when there are access issues, lower resource disturbance on the ground since sites don't have to be accessed as frequently. There are time savings since people don't have to travel to camera traps, and that time can just be invested elsewhere. And ultimately, there's no, compared to, let's say, mesh networking solutions, using satellite, there's no infrastructure needed. So solar powered, uses satellite communication. So it's just easier and more cost effective to set up than actually dragging the cable out into the field.
Okay. All right. And then Bill? Thanks.
Yeah, for the first question, trying to remember what the first question was. Oh yeah, how does it improve on current methods? There are a lot of things that have been tried to reduce raven predation on tortoises. Most of them haven't made big impacts. It's still occurring. Lethal control is one of them that has that it removes a problem bird, but there are so many of them that it's not a really good solution. Egg oiling is helping, but that's focused on specifically on nesting birds. This is just another, using Technotorch is just another tool in the toolbox. And as far as helping the species of desert tortoises, the idea is that it would train the ravens, whether they're nesting ravens or other ravens, not to prey on the tortoises. So hopefully it will have a pretty big impact.
Okay. And then Charles. Thanks, Bill.
Mm-hmm.
Where tick collection is concerned, it's traditionally been done manually, and obviously sending humans out to collect potentially disease-infected ticks, probably not a good idea. So yeah, we figure having an automated solution would keep people out of harm's way and also allow you to, detect illnesses before that they can spread through the ticks, and also by being able to identify geographically where you can most likely be finding ticks in a large, a high density of population. It means that you can direct your remediation efforts more efficiently. Try to eliminate the ticks before they can become a problem.
Okay, that sounds great. So I think that's we're now a little bit over, and I know that we are. I guess technically we have 10 minutes afterwards, but I wanted to thank everyone. And if anyone in the audience had questions, feel free to stay. We can continue to chat about it. But I'd like to thank the audience and the panelists for participating in this session, and I hope it was useful to everyone. Thank you very much. And thanks for sticking with us with our technical difficulties at the beginning. Okay.
Thank you, Gene, for
hosting this.
Yeah, thanks a lot, everybody.
All right. All right. I'll monitor for any questions, you guys. If there's anything that comes up, I'll announce it for you. Thank you.
Thanks.